Welcome back to Advent of Code 2016. We're on to day 20, the final week before Christmas Day. It's not been that hard, to be honest, so far. I think the hardest was, what was it? This one, 11, the elevator one. That was quite hard. Okay. Let's begin. 20. Firewall rules. You'd like to set up a small hidden computer here so you can use it to get back into the network later. However, the corporate firewall only allows communication with certain external IP addresses. You've retrieved the list of blocked IPs from the firewall. But the list appears to be messy and poorly maintained, and it's not clear which IPs are allowed. Also, rather than being written in dot decimal notation, they are written as plain 32-bit integers, which can have any value from 0 through to this number here, inclusive. For example, suppose only the values 0 through 9 were valid, and that you retrieve the following blacklist. Okay, so there's IP addresses from 0 to 9. That's the address, just 0, 1, 2, 3, or up to 9, okay. And they're blocking 5, 6, 7, 8, 0 to 2, and 4 to 7. So what, it would just be 309? 309. Blacklist specifies ranges of IPs, yeah. The only IPs that this firewall allows are 3 and 9. Given the list of blocked IPs you retrieved from the firewall, what is the lowest value IP that is not blocked? Oh, I see. This is a range thingy. All right. What's the trick here? So you can't just create a hash set or something. You have to use a range. Well, no, you sort the ranges according to the right hand side boundary. So you would put 0, 2 first, then 4, 7, then 5, 8, and then what? You lowest value IP, and then you just go through them one by one until you find a pair that are non-overlapping, right? You sort, and then it'll be clear. You just go through them one by one. You look at 0, 2, and 4, 7 side by side, and you can see that there's a gap between them. Is that it? Yes, because if there is a gap, if there is an IP that is not blocked, then there must be either there's no ranges to the left of it ever, or there must be some range to the left of it, some range to the right of it, and then non-overlapping. Okay, all right, this is easy. Okay, so 20. Huh? Thought I saved the input. Alright, we'll just copy and paste it. We need so read the inputs, so let's just make a list of ranges. While with I can't even remember how to do this. Look at this one. Yeah, that's the one. Oh, can I make this a bit bigger? Okay. A, B equals int x or x in f dot readline dot split on the Python. So that will get the two ints. Put ranges dot append AB. And now we sort according to the right hand side. So this can be a little tricky. It's not immediately obvious what you do about overlapping ranges. I mean, there's lots of algorithms to deal with overlapping ranges because it's an important area of algorithm use. Key equals lambda pair to the right hand parameter. Now for so I guess we just have to separately check if 0 is covered. So if let's define get lowest so we say if the first pair actually is above 0, then we return 0. That's not going to happen, is it? But whatever. Let's try and make this a proper function. So, okay, so now for I in range length array -1. So we check every pair against the next one. if why am I hesitating? This is not hard. Just do if array so I the second parameter is less than is at least one away, or let's say at distance 2 or more from the next one. Return this. It's not covered. Hang on. This doesn't work as is. Oh, no, I'm missing something. I still got to because there might still be a pair later on that covers it, because I've only sorted by oh, what are you supposed to do here? I think you can just replace these ranges with okay. We okay, we just say lowest known so far is 0. Every time we come across a range, it doesn't even need to be sorted, does it? I was doing something a bit more complex. You can actually just you just say for pair in array if array if lowest lies in that pair in that range, then we change lowest to be the next integer available. So the sorting is not needed. We can actually just oh no, you do need the sorting. Yes. Because we need to go by the, yeah. So this is so if array so if the first if lowest is within this range, then now the new lowest is array 1 plus 1. Is that it? And is this sorting the right? Is this the correct sort to do so that this works? should be. Alright, let's try it then. Lowest is necessarily equal to array. Oops. What? No, it's pair. Zero. Get lowest. Yeah, they never cover zero. Have I completely misunderstood the... What is the lowest valued IP that is not blocked? So do they ever actually start from zero? Are any of these ranges... The lowest valued IP that is not blocked. So these ranges are blocked. So do they ever start, let's see, start from zero? Well, let me just... Huh? Oh, for goodness sake. Alright, I didn't go through all the lines, that's the problem. There we go, 32259706 sounds plausible. Correct. Yeah, that's the trick. Sorting by the end point. It's not even really very intuitive. It requires a little mathematical proof to show that it works. But whenever you deal with ranges, you should sort by the right-hand side interval. It's the like the event scheduling problem or something. All right. How many IPs are allowed by the blacklist? All right, this time we actually want to create a data structure to keep track of this. So okay, so we want, let's say, intervals. We're going to create a new set of intervals, but then they are the same range, but summed together. So basically, the union of all these ranges. And if we sort by the right-hand interval, it'll be efficient. Actually, in this case, it doesn't need to be sorted in any way at all. Oh no, actually it does help for it to be sorted. All right, so we say or pair in array. Okay, so all right, so we've got a pair. And we want to add this to our intervals list. But if it overlaps our last interval, we delete that interval and create a new one. So if pair 0 is strictly greater than intervals -1, so the last thing we added, and the right hand side, then we just put this in the intervals dot and pair. Else, the only other possibility is that it overlaps with the current one. So let's say new A equals min of pair 0 intervals -1 0, so that the left-handmost point, and then we say intervals, delete whatever is at the end of intervals, and now replace it with a new range, which is the union of these two, which is done efficiently. So new, let's call this left. Why did I call it new A? Left. And pair 1 will be the right hand side. Now, by the end of this, intervals will be... so we say the number of blocked items is going to be the sum of the lengths of all these intervals, right? So it'll be sum of pair 1 minus pair 0 plus 1 for pair in intervals. So print the what's the full number of this one? If pair... there's nothing in intervals to begin with, so if not intervals, or there's nothing in intervals. Yeah. What the Also, it should be 6, add 1 because of the 0. But still, Okay, print intervals. What's going on here? Oh, this doesn't look right. What is going on here? No, this doesn't look right at all. So if not intervals or, this new pair is strictly to the right. Let's say, no, we should actually do +1 because there's no gap between them. Try that, run it again. So now there are gaps between them. How on earth do we get a minus number? How does that happen? These should all be blocked equals. These should be non-overlapping now. So blocked is... What's going on here? Oh. That's how many blocked ranges we've got. So the only explanation is that these are still overlapping. We haven't correctly... How could that happen? Pair in array. Yeah, so we're taking the union, and it looks correct. There's the proper. They're leaving the gaps. Ah, we could have duplicates. Hang on. What happens if there's two duplicate ranges? Uh, if pair 0 it's fine if there's duplicates. Oh. Oh, there is a problem here. Yeah, I see the problem. Ah, no, this is wrong. This is wrong. Their left point could interfere with all our previous intervals because there's no bound for how far left it could go. No, what? Oh, no, this is not how you do it. How do you do it? There's a technique for creating the updated ranges, and it's you start by sorting them by the right hand side. I think that's correct. And then what? Well, do we sort by the left-hand point instead? Yeah, I don't think the right-hand point helps us here. 32259706. Let's change this. Sort by the left-hand side. So we get the same answer there, that's correct. And now, okay, it looks like we've got something. Let's see if this is correct. Yeah, that will ensure that we don't, any new interval is not going to interfere with, overlap any of our previous intervals. Yeah, this is the correct order. Oh, damn it, I was showing the browser. How long was I showing the browser for? Okay, so, oh man, I was probably showing it for ages. Okay, so... that's the number I've got now. So we're sorting it according to the left hand, not the right hand, edge of the pair. That way we only have to deal with the last interval added. Merge intervals together, but we never have to merge with intervals further back, otherwise that's a mess. Well, let's see if it's correct. Too high. Did I, hang on, so did I use the correct number here? So I did minus blocked. Should it be do these intervals look okay? Yeah. We have larger gaps now. That's correct, I guess. Alright, let's test it on the example then. So in this case, it would be 10. So it says 2 are unblocked. That's correct. It's not a very... I mean, this example doesn't even have overlapping, so it's not a very useful example. Okay. What could be the problem now? Now, we can't assume the right-hand side will be pair 1, because it's no longer sorted according to the right-hand side. So now we need this right equals max pair 1. There we go. We don't have the correct right-hand sides. Oh, why did I put max there? Right. Only 113. Actually, that sounds plausible now, because it did look like they were leaving very small gaps. So yeah, we were way too high. All right, cool. Yeah, so it's basically a problem that gets solved by sorting, but it's not. It's something that's tripped me up several times in the past. Range trees, range queries, stuff like this. It's not easy and it's not intuitive. You have to think carefully about it. But usually the answer is sort first. Once it's sorted, then you can maintain invariance. Now, will ChatGPT be able to solve this? Because this is a tricky one. People not familiar with this, so. Okay. All right, find lowest allowed IP. Gotcha. Sort by their starting IP. Yeah, that's correct. Okay, as long as you sort either by start or end for the first part, it's fine. Okay, we'll check that this works. Yeah, that's correct. Okay, so 3225976. All right, part 2. Huh? I don't think this will work. Why would this work? Is he assuming they're gonna be non-overlapping? Hang on. Were they ever supposed to be non-overlapping? Maybe this problem is easier than I had thought. Maybe they can overlap, but the thing is they never said. So I've just solved a harder problem? Alright, well we can try this. No. Well, let's test it. 113, it works. Wait, so... If I just change this to, change my program to forget about intervals, just use the original ranges. They do overlap. Wait, so why is this code so simple? Have I not understood it? The start, end, and blocks ranges. If highest IP is less than start, allowed IPs. Oh, I see. He's not storing the ranges, he's just summing them as you go along. It's the same as what I did, but he's not storing the intervals because you don't need them after that. That makes sense. And you're keeping an endpoint. Oh. Yeah, that's better than what I did, because unless you actually need the cleaned up interval tree. Right. Fine. ChatGPT wins. Alright then. 21. See, that wasn't that was still a tricky problem then. Let's have a look at the stats. 20. Huh. Well, this people didn't seem to have any more difficulty than in the previous problems. I suppose if you think about it long enough, you will realize about the sorting. It's not that unintuitive. It's just you can go down a wrong path of trying to do complicated things like splitting up ranges and stuff. All right, 21. Scrambled letters and hash. computer system you're breaking into uses a weird scrambling function to store its passwords. It shouldn't be much trouble to create your own scrambled password so you can add it to the system. You just have to implement the scrambler. The scrambling function is a series of operations. Starting with the password to be scrambled, apply each operation in succession to the string. The individual operations behave as follows. Oh my god. There's a lot of them. But I don't see anything difficult here, you just have to do them. Swap position X with position Y, that the letters are indices. Should really be indices, shouldn't it? X and Y should be swapped. Okay, so we need to use a list, not a string. Swap letter X with letter Y means that the letters X and Y should be swapped. Ooh. Ooh, okay. Interesting. Okay. How many operations do we have here? Oh, not that many. Okay, so we can actually we don't have to be clever, like keeping a table and then applying things at the end. We can just do all these steps. All right, rotate left, right means the whole string should be rotated. That's easy to do in Python. Okay. Rotate based on position of letter X. Index of letter X. Okay, reverse positions X through Y means that the span of letters at indices X through Y should be reversed in order. Fine. Move position X to position Y means that letter which is a... Hello, Amaro. Alright, this one just looks a bit tedious. We just got to implement all these swaps and rotations, but means that the letter which is at index X should be removed from the string, then inserted such that it ends up at index Y. Okay, fine. Let's do it. After these steps, the resulting scrambled password is decab. So we need to scramble this word here. A, B, C, D, E, F, G, H. Okay. One. All right. So we've got all right. So password equals that. And okay. So input. All right. So we strip and split, as always. now we do basically switch case. So if it's swap, no, well, let's do them in order that they were listed. So if it's swap position, okay, if tokens 0, tokens 1 is swap position. All right. Password will have to be a list, not a string. Okay. So if it's swap position, then we have to do a simultaneous swap. So ij equals int tokens. So it's 0, 1, 2, 4, 5, 2 and 5. So we do password I, password j equals password j, password I. All right. Otherwise, we've got swap letter x with letter y. Okay. Letters are unique, aren't they? Yeah. Okay. So we can actually just index them. So. So now it's going to be letters 0, 1, 2, 3, 4, 5. Okay, so A, B, it's going to be then we do I, J equals password dot index. Okay, so just do it like this. Okay, so that's that one done. So now the next one is just run this, make sure there's no errors. Okay. The next one is rotate left, right, X steps. All right. Let's start with the next one because it's easier to do the switch case. So rotate based. Let's do rotate based on position of letter X. I don't like this problem. It's just tedious. All right. Elif. So based. All right. So rotate based on position of letter X. The whole string should be rotated to the right based on the index of letter X. Rotate the string to the right one time, plus a number of times equal to that index, plus one additional time if the index was at least 4. Okay. Okay, fine. Based on position of letter, so 0, 1, 2, 3, 4, 5, 6. Steps equals, so one plus the index, so it'd be so it'd be 1 plus index plus, so it's one if the index was at least 4. 1 if I is at least 4, else 0. Okay. Now, what does it mean to rotate a string to the right? So we need to find the splitting point. So split point equals length of password minus steps. So password is replaced with password from split point onwards, concatenated with password up to split point. Now this could be larger than the number of elements, so we should length of password minus steps, or just do this. It's minus steps percent and passwords. That means if we rotate fully and keep going, then it'll use modular arithmetic. So just pick the cancel it down. All right, so passwords. All right, just make sure that runs. Okay. What does the password look like after this so far? Hegemon. Okay, fine. So far, so good. Elif. The other form of rotation, it's steps. Okay, steps equals int tokens zero, 1, 2. Okay. So we want split points. So if we're rotating right, it's minus. So it'll be -1 if tokens 1 is right, else 1 multiplied by steps. And now we just do that again. Alright, getting there. What else? Reverse positions X through Y. Okay. Be reversed. Alright. So if it's reverse, see, this is a problem that ChatGPT will really excel in, because it's really tedious to write these out, but it's simple. It's in simple, straightforward language. So this takes a long time to code, but ChatGPT will be able to solve it quickly. All right, so do 1, 2, 3, 4. So password equals password up to I plus password I through j plus 1, but we want to reverse that. Do you just put the -1 here? I'm not good with slicing. Let's just do this because that's what I normally do. Plus password j plus 1 onwards. I can't imagine doing this in another language. This has to be done in Python. Python is the only way for this. Right. And then the last one is move. removed from the string and then inserted. Wait, I don't understand move. Exactly. Move 1 to position 4. Oh, I get it. Okay, fine. Yeah. Move. Else. So we do 0, 1, 2, 3, 4, 5, 2 and 5. So character equals password I delete or password dot pop I and then password dot insert equals password dot pop I, and now insert character J. Alright, is that all the steps? Oh, J comes first. That's the final password. It better be, because this is going to be a nightmare to debug. Correct. Okay. You scrambled the password correctly, but you discover that you can't actually modify the password file on the system. You'll need to unscramble one of the existing passwords by reversing. No! No! Do all that in reverse. How easy is it to reverse? Some of these steps are easy to reverse. In most cases, you just swap. I's and J's. Okay, hang on. So you need to. Can't actually modify. Okay, you need to unscramble one of the existing passwords by reversing the scrambling process. What is the unscrambled version of the scrambled password? It's alright. So it actually matters what order you gotta go. So we gotta go backwards now. Oh my god. Okay. It's a bit of big chunk of copy pasting, so alright. Switch back to so we need to unscramble now. So we do this again. Do this whole thing again, but we need to reverse every one of these. In some cases, they don't even need reversing. It depends what's going on. So open. Okay, we go backwards because the order matters as well. So we go backwards. Right. If it said swap positions, then that's fine. We just do the swap again. It's what's the word? If you do something twice, idempotent? No. It's self-inverse. Alright. So that's fine. If it's swap letter, then that's also fine. Actually, some of these, okay. Rotate. So this one, we change right to left. Oh, wait. rotate based. Ooh, this one's weird. Hang on. So that one I'm not sure about yet. Just leave that. So rotate is easy. We just change the minus sign. So it's 1 if tokens equals right, else minus 1. Okay. Reverse. That's fine, just keep that. It will... That's self-inverse. And then the final one is... make it end up at I. So if we're taking from I and putting in J, then we're swapping these around. So we're saying J, certain I. Alright, so the one that is confusing me is rotate based. Based on position of letter. So we have to find we have to find out what the original position of letter A was. It's not clear because it's not. We have to go backwards. I can't visualize this. Wait, so rotate based on position of letter A. Let me look at the examples. So find the index, then rotate the string once, plus the number of times equal to that index, plus an additional time, because the index was at least 4. Okay. So if we were told that we rotated based on the position of letter X, we now have a password and an X, and we're told it was rotated based on its original position. There's probably only one unique position it could have been, so I guess we can just try all possible original indices. Yeah, let's just do it that way. This is a bit confusing to inverse. So I equals let's make sure this runs. Okay, so for index in length password, index in range, I mean, range, length, password. If it was at that index, then we would do this. Steps equals that number new index equals, we rotate right, that means we push it forward, so it'll be index plus steps percent because percent and password. Wait, I don't need to do this for loop. Okay, so this is reversible now that I've written it out. You just want to say, I want to find what index was from this equation. If new index equals that, so we take this. So we take new index equals password dot index I. This is where it is now. So we want to say steps equals new index minus index so now we know the number of steps. Okay, and now we have to work out if they added the 1 or not. I don't know why I'm finding this confusing. It's not that confusing, it's just this logic condition. Okay, fine. So we say if if steps equals that's correct. Okay, that's the number of steps, that's the number of rotations I've made. So if we subtract 1, that should be I plus that boolean. So if it's, say, at least 5, wait. Okay, so it'll be why? Okay, if it's greater than 4, that's basically the rule here. If steps minus 1 is greater, strictly greater than 4, it can never be 4. Because if it were 3, you wouldn't add the 1. If it were 4, you would add the 1 and you get to 5. Okay, so then the original I was Okay, just do it like this. If steps is greater than 5, it will be steps minus 2, else index equals steps. That's 1. And then finally, we do split point equals what am I trying to? What? I've mixed this up so badly. Hang on, what am I doing here? What is index? Something's... There's no index yet. I've been using a variable I don't have access to yet. This shouldn't... We don't have this. Take this out. Alright. What is... Okay, the final position is new index. Okay, that's for sure. Okay, take this out. No, why am I using index here? That's all wrong. So what am I actually trying to do? I'm trying to say, I now know where this letter is. Where was it before? Is there... How? There's a unique place it could have been, right? But how... Do I just try all values then? Like I was doing initially? Isn't there a way of directly calculating it? So if I know where it ended up, I want to find the I such that so it's basically that new index equals yeah, okay, if I write it like that, get rid of steps, just write it like that, that's clear now. New index equals I plus 1 plus I plus that. Okay, got it. So new index minus 1 equals that. That's 2i. 2i would be right. So steps doesn't matter. Let's just say so if new index minus 1. So if I was 3, it would be 2 times 3, 6 plus 1, 7. No, it would be 6. 3 would go to 6, and 4 would go to 8 plus 1, 9. So if new index is strictly greater than 7, we know it must be in the latter case. So I'll just say strictly greater than 6. That means I equals that minus 2 divided by 2. Else it will be that it's 1. Why did that give me so much difficulty? It's not that hard. All right, get rid of this now. New index equals where it is now. Now we know what the original I was, and then we just do the original steps. So we say steps equals the original calculation, which is okay, steps equals that split point would be that, except we're now going to add instead of subtract because we're going left. And that will be the final password. Oh my god, what a mess that one was. I probably done it wrong as well. Let's try. Is it that? They haven't given us an example for this, so. Nope. Bollocks. What is the unscrambled version of the scrambled password? Alright, we have to go through these again and see if I've reversed them correctly, so. So we know how to scramble. Why don't we try to unscramble the thing we started with? So let's say this thing we scrambled to begin with, see if we get back A, B, C, D, E, F, G, H. Well, we don't. So let's see, swap position. I, J, that's fine. Okay. Swap letter. That's fine. Rotate base. Let's leave that till last because that's probably wrong, to be honest. But let's check all the others first. Rotate. Steps. So I copied the original rotate, but I've changed the -1 to a 1. So yeah, that's changing a minus, multiplying it by -1 should just reverse the rotation. Okay. So that's fine. Reverse. Should be that should be self-inverse. And then this one, J, pop, What's that J? And now make sure it's inserted into I. Originally it was pop I insert into J. Yep, that's correct. So the rotate based is wrong then. New index is password.index token 6, 0, 1, 2, 3, 4, 5, 6, letter H. So we found where H is. Gotta write out the formula again because I can't understand this. Alright, so rotate based. So this is what steps looks like. So we've got a new location for this letter. We're trying to find out what the original location was. So we need to, and it was rotated to the right by steps. So if it's rotated to the right, so new index will be the old index. So if you rotate to the right, you're adding. So it's old index I plus the number of steps, which is that. So it's 2I plus 1 plus that. So new index minus 1, move the 1 over, it's that. So the turning point is when between I equals 3 and I equals 4. If I equals 3, then it's 2 times 3, which is 6, plus 0, so it'll be 6. So if it's greater than 6, that means I was at least 4. So then it'll be, you have to subtract an additional 1, move the 1 over to the left, so it'll be new index minus 2 over 2, yes. And if it wasn't greater than 6, then that means I was, this section here is 0, so I will be new index minus 1 divided by 2. Alright, so we've got I, we know what I is. And steps is just I think we're not I think we're not accounting for for going off the end here. New index might be less. So not. Ooh, that's the problem. New index minus. Oh, wait. New index was I plus steps, but you need to modulo out. So if you roll off the end, oh, this is so confusing. Let's go back to what I was doing originally and just do the for loop. This is stupid. All right, so how do I fix this? Do I just say, do I do a percent here? No, not here. Where do I? The multiplying by 2 is problematic because it might. We do probably have to do the for loop, because if you multiply by 2, you can't inverse that in the modulo world, because 2 times I might be smaller than I, because you multiply by 2, but then you also have to modulo the end of the string. That's okay. Go back to what I was doing before. For I in range length of password. Okay, so yeah, so we take steps equals that. All right. Yes. Okay. New index equals I plus steps. And then this is where we put the modulo. This is really the only easy way to invert the modulo operation, because percent length password. If new index is the same as that, break or just do the rotation. So now we know what steps is. We just have to go backwards. And there will be one value where that will work. So we can take all this out. Alright, try this. Oh my god. Got the original string. Okay, now let's use the actual. Oh, I forgot to switch to the IDE again. Oh my god, this video is gonna be horrible now. It's just gonna be staring at the web browser. I need to find a way of remembering to switch. Okay. Anyway, it's not going to be a pleasant watch. This was horrible to code. Right, so we start with that. We invert every operation, and we get that. Okay. Oh my god. Alright. I said that ChatGPT will find it easy. Now I'm not so sure. There's a lot of little things it could get wrong. Oh, Christmas tree has appeared. Okay, so all right. I see he's making this functional. That's smart and not what I did. Yeah, yeah. Don't really want to look through this. It's. I think he gets it. So let's try now. Process operations. Wait. Invalid literal for int with base 10 position. Just first make sure I copied the code quickly. I think he's made a bug. He's reading the tokens wrong. I bet it's because he's copying what someone else did in the past. So. Nope. Okay, might have fixed it. Map int operation dot split through. No, doesn't. He's similar error. Has he got this error in all of his parsing? Alright, let's just. Nope, still getting an error. I don't see much changing. He's not... I don't think he's really solving this at the core of the... I think he's not finding the core issue here, he's just adding on workarounds which aren't actually solving it. So this could be a fail. So is he just going through these one by one, these methods one by one, and fixing the issue instead of fixing them across the board? Alright, it works now. It took a few tries, but that's it worked. Wait, so BG factor. Alright, BG factor. Yep, that's correct. Now, part 2. This is gonna be interesting. This is something he'll probably get right, because it might not. I don't know. I wonder how he's done the... If index percent 2 is 1, index plus 1. Index equals index divided by 2. Yeah, but you're doing... I'm not sure... Why are you adding 1? Yeah, what? Alright, whatever. Test it. I don't understand the modular arithmetic stuff. It's been a while since I've done this stuff. Maybe he's doing it correctly. Operations is not defined. Forgot to give us the we forgot to read the input. Alright, fine. Swap position is not defined. What the heck? Well, damn it, he's not giving us the full code. I'll just tell him that. Alright, he's generating it. Yeah. The full code. We need the full code because... Okay, so... Is this actually... Okay, fine. He's now renamed them, so it's... Okay, fine. Unscrambled password. I don't... Wait, no, it's wrong. But I don't think he's actually unscrambling now. Is he scrambling again? He's named it... Should be BDGH. Right. Rotate based on position of letter. Should go to the right instead of the left. Right. Wait, no, it shouldn't. It should. It should go left if you're unscrambling. I don't know what he's doing at this point. He can't decide whether he's scrambling or unscrambling. Ah, no, that's correct. BDGH. BDGHEACF. Alright, I mean, I wasn't looking into fine details, so I guess what he's done is right. He got there in the end, and he still got there faster than I did. Took me forever. So... that's a win. For ChatGPT. And that brings us... Okay, I'm going to finish there. That brings us to day 22 next time. There's just 4 more problems left, and 25... Let's have a quick... No, we don't need to take a peek. It should only be 1 part. It normally is only 1 part. So that was 21. So it looks like the next problems might be a bit harder. Okay, the next one, a lot of people just didn't get past part 1. There's a big amount of silver here. Not that many, though. Right. Okay, then. See you next time.